Elimination method for systems of equations. This particular example asks us to solve each system of linear equations using the elimination method. Now, this is kind of an ideal example of a system that works really well with the elimination method because the x's are lined up in the two equations, the y's are lined up in the two equations, and the constants are lined up in the two equations. Both of these equations are in what's called standard form. So when that's the case, little has to be done in order to solve for both x and y. So I do typically rewrite these equations because we never want to change the original. So in this case, even though we're leaving the equations the same, we just rewrite it as x plus y equals -4, and the opposite of x plus 2y equals 13. Now, elimination is simply adding the two equations together or combining the two equations into a single equation. Well, going back to opposites making 0, we're left with just 3y equals 9. Undoing this equation or isolating the variable y by solving the equation gives us y equals 3. Once again, going back to the original equations to solve for the second variable, we would rewrite the equation as x plus 3 equals -4. 3 is substituted in place of y. Undo the equation by using inverse operations, subtracting 3 from both sides, and we would get x equals -7. Using the second equation, we once again substitute in place of our variable y, and it's really important to use the other equation because we want our x values to agree when we solve for them. In this case, we get the opposite of x plus 6 equals 13. Undo that by saying, subtracting 6 from both sides of the equation, and we're left with the opposite of x equals a positive 7. We undo a negative x by dividing by -1, and we get x equals 7, which shows that both equations agree, meaning we have checked our solutions. We always write our coordinate pair as -7, 3. The x value first, the y value second. That's alphabetical order. With the next example we have here, several things are happening. We've got one equation in standard form, the second one is not. So the first thing we want to do is solve this particular equation, or put this equation into standard form. That would be 3x minus 4y equals 2, and that was simply subtracting 4y from both sides. Leaving these two original equations alone, we rewrite it as 5x plus 6y equals 16, and write it as 3x minus 4y equals 16. Equals 2. Now in this case, it's not quite as easy to eliminate by combining these two equations. So we need to change the two equations so that it eventually eliminates one of the variables. With 5 and 3, the least common multiple is 15. So I want to use that idea to eventually eliminate. But if I leave it positive, I'm going to end up having more x's than I want to work with. So in this case, I'm going to multiply the top equation by -3 because that will give me a -15x plus a -18y equals a -48. The second equation, I'm going to keep that a positive factor right here because then we'll have a positive 15x, a -20y, and a positive 10. Now when we combine these equations using elimination method, we have our opposites make 0. We're left with the opposite of 38y's equals -38. simply solved by dividing both sides of our equation by -38. We're left with y equals 1. Going back to our original equations, the ones that we never touched, we would substitute in place of y. So we have 5x plus 6 groups of 1 equals 16. Simplify that, and we get 5x plus 6 equals 16. Isolate the variable x by using inverse operations. We subtract 6 from both sides, and we're left with 5x equals 10. Undo that by dividing both sides by 5, and we're left with x equals 2. I think you can tell how much work is involved here and how important it is to keep your evidence really neat. I'm going to move this particular piece of work over a little bit here. So once again here we substituted in place of y, and then we evaluated simplifying the expressions first, and then we solved for our variable x, and that agrees with what we had done at the beginning. Once again, when we write our solution to a system of equations, it's a good idea to put that in the form of a coordinate pair, which is the x value first and then the y value.